In this video, we'll be graphing y equals -3 times the square root of x minus 2 by transformation and state the domain and range in interval notation. Anytime we're graphing by transformation, I like to start by writing out my plan, what my transformations will be. We start by identifying our parent function, which will be y equals the square root of x. And now we're checking for our transformations in order. The first transformation we're looking for is a horizontal shift. We recognize that when we have plus or minus a number inside the function. And in this example, we do have minus a number inside. That tells us that we are going to have a horizontal shift. And our direction is always opposite the sign we see. So we are going to be going 2 to the right. Next, we want to look for a horizontal reflection that occurs when we have multiplication by a negative inside the function. We don't have that. Next, we're checking for a horizontal expansion or contraction. We recognize that transformation when we have multiplication by a number inside the function right in front of the x. We don't have that. The next transformation we're looking for is a vertical reflection. There's a vertical reflection when we have multiplication by a negative outside the function, and we do have that in this example, negative on the outside. Adding that to my blue equation. Remember that we're always building off of the previous equation. Just like when we go to plot the points, we'll always be building off the previous graph. And then negative on the outside, like we said, it's a vertical reflection, a reflection about the x-axis. And it's going to affect our points, so we're going to have to multiply all the y values by -1. The next transformation we're looking for is a vertical expansion or contraction. We recognize that that transformation is going to occur when we have multiplication by a number outside of the function. And in this example, we have that. There's 3 on the outside. Multiplication by a 3 on the outside. Since that 3 is greater than 1, this is going to be a vertical expansion. And we are going to multiply all of the y values by 3. There's nothing left up there with our original equation. The last transformation we check for is a vertical shift. We have that when there's plus or minus a number outside the function, but we don't have that with this example. All right, we have our plan. Let's execute. The first thing we need are the points for our parent function, y equals the square root of x. That passes through the points 0, 0, 1, 1, 4, 2, and 9, 3. You don't have to memorize the points for the parent function. You can always make yourself an XY chart and come up with the points. After a while, you might have them memorized. I sure do. All right, so we're going through 0, 0, 1, 1, 4, 2, and 9, 3. Now that we have our parent function graphed, we're ready for our first transformation. And remember, if you're ever having trouble kind of keeping up with the video, make sure to pause it and carefully draw on your graph and then replay the video. All right, our first transformation of shifting 2 to the right. I know visually what I'm going to see, but I also want to get my list of points. Since we're shifting to the right, that's horizontal. Our horizontal component, the x value, is what's going to change. And we're going to add 2 to all of those x values to get our new points. 2, 0, 3, 1, 6, 2, and 11.3. And we're going to just see our graph shift 2 to the right. And there's our second graph in blue. Our next transformation is to reflect about the x-axis. I've already noted that I need to multiply the y values of my blue points by -1 to get my new points for the green. So let's do that. We'll have the points 2, 0, 3, -1, 6, -2, and 11, -3. Visually, we should see everything that was above the x-axis become below, and anything that was below should now flip above the x-axis. We'll plot our points. And there we have our third graph. One more transformation to go, a vertical expansion. We're going to multiply all the y values from our green points by 3 to get the points for our final graph. That'll give us the points 2, 0, 3, -3, 6, -6, and 11, -9. Plotting those points. Here's our final graph in red. The last thing we need to do is state the domain and range of our final red graph. The domain, all of our x values, we see that we start having x values at 2, and we're using a bracket because we're including 2, and then the arrow to the right tells us positive infinity. The range, we start by having an arrow pointing down. That starts us at -infinity, and our red graph stops right there at y = 0.